we handed out for today a gas law help sheet, and we've added a few things to it, one of which is Graham's law that's on the board right now. We also said on the first page that the M was molar mass, right? And that N is equal to mass divided by that capital M, which is molar mass, not molarity. Okay, so what we're going to do now is we're going to go into the practice problems of gas laws, because we really need to practice these gas laws and be really familiar with it, because there will be a test question with gas laws. Every year there has been. Okay, so I want to look at these problems. I'm going to do some of them with you, and if you'll notice at the end of this packet, there are actually some actual AP questions right off different exams that have to deal with gas laws. Now, they are starting to do a lot more with particle, being able to visualize things particle-wise. So we need to make sure that we're watching being able to visualize how fast a solid moves compared to a liquid or different temperatures. It's okay. All right. Yeah, so to be able to draw. And so there, you'll also see on the next page, there's some visualizing things. Okay, so we're going to look at this. Hopefully we can read this when I move this up. Oh, yeah. Okay, so here we go. We're going to go through the first 10 together, and then I'm going to have you do the next bit by yourself. So write down some examples. Here we go. So a gas at this, what is that? Pressure. So I put a P right by it. Measures at, what is that? I'm trying to find volume. What's standard pressure? Pressure, standard, since this is in millimeters, I need it in millimeters if you don't know. Yep, 760, look at your little cheat sheet. Millimeters mercury. Okay, whose law? What's held constant? Temperature's held constant means Boyle's. Okay, so Boyle's law is P1 V1 equals P2 V2. I'm solving for V2. I always like to rearrange it before I put numbers in. You don't have to. Okay, so P1 V1 divided by P2. Plugging in 680 millimeters divided by 760 millimeters, and then on the top I'm also timesing by volume of 1,000 milliliters. Millimeters go out, I'm going to end up in milliliters. If you don't have a calculator, I've got a whole bunch out there. Grab it. Oh my heck. Lazy butt. Over the break. They are not.
Yes,
They work their butts off.
Let's be real. When they're not doing science, they're lazy.
Oh, no way. They're always figuring out something. What do we get? Okay, how many significant figures?
2, 3, 1.
There's one. Now, I'm going to assume,
Wait, 1.
yeah, this
She's right.
is one. So what do I report?
900.
900. Thank you. Okay, we're not circling or squaring our answers, right? We're just putting them over so we can identify them. Okay, as a gas measures 8 milliliters, what is that? Volume. At standard pressure, what is standard pressure? Well, I'm looking at it and I don't need to know anything. I can pay atmospheres. Yeah, let's do 1 atm. Okay, what volume? Okay, so I'm looking for V2. Will occupy if the pressure is doubled. Well, this makes it easy. If I use atmospheres, pressure double is 2 atmospheres, right? It's Boyle's law again. So, and I'm looking for V2 again. So I'm not going to rewrite it. I'm just going to take it from what I have up above, and I'm going to plug in. So 1 atm times 8 milliliters divided by 2 atm gives me 4 milliliters.
Boom.
That's right. If you used your calculator on that, there's no hope for you.
So I use my calculator to add.
Okay, so let's look at the next one. A quantity of gas under a pressure, so here's my P1, equals, has a volume, V1, equals, the pressure increased to P2. What volume? Again, I'm looking for V2. Oh, I'm looking for, no, V2. V2 again. You said P2. It's okay. They do. Okay, so plugging in 720 millimeters times 300 milliliters divided by 800 millimeters equals how much? How many should I report? 300. 1. Because 300 only has 1, 800 only has 1. If they had put a decimal after, then I would have 3 significant figures. Okay, I would have 2 if they put a decimal after each one. Okay, so let's go on the next one. Find the volume. Okay, so we're finding the volume if, so this is also volume. If the temperature is increased from, here's T1, here's T2, so this must be V1, and I'm looking for V2, right? So whose law? What's held constant? Pressure, Charles. So it's going to be V1 divided by T1 equals V2 divided by T2. What's special about when I have temperature?
You gotta change it.
How?
Celsius to Kelvin.
Celsius to Kelvin by adding 273. It's not going to worry. I'm not going to worry about the 1.5 because I don't have 2 significant figures, and adding 273, I'm going to get more significant figures. So I'm going to add 273 to both of those. And why am I going to get more significant figures? That sounded wrong, right? Why am I going to get more? Because I'm adding and I'm going to the ones place. So I'm going to get more. So I'm going to 0, 8, 280, and 5, 305. Is that 290? Yep, 90. You're right. Hey, that's why I do this so you guys see if you're really awake or not, right? I'm not. Okay, so these are both Kelvin. All right, so I am looking for V2, so I'm going to rearrange it because I told you I like to rearrange first. V1, T2, T1. Plugging in 150 milliliters, and you're going to want to write these out. Don't just assume that the reader knows what you're doing, because half the time we have no clue, and we can't assume anything. You've got to tell us everything. Okay, 290, okay, K's go out. I'd like that. That would be an awesome number. Okay, what do we get?
Well, 157. Figures. 7.
What do we get?
160.
160. Okay.
We don't have to put it in cc's.
Milliliters are cc's. 1 milliliter is equal to a cubic centimeter, right? Okay, so here we go. Next one. Volume. Boy, honestly. Volume of a gas at a temperature. If the volume at the standard temperature is, so here's my volume. What's standard temperature? 0 for gases. It's going to be 0. So that's going to equal 273, right? I only have 2 significant figures, actually 1 right here, but when I add 273 to this, I'm going to get what? You get 2 significant figures, but we'll carry the 3 anyway. 12. Okay. And whose law again? 323. Charles. So we're finding the V2 again, right? Uh-huh. I want you to get used to showing me exactly what you're doing. Because if you show me exactly what you're doing, a lot of times I'll give you 1 point for just showing this. Are you guys seeing me? You get 1 point just for showing me this.
So should we have done that?
Yeah, we did. Okay. So T2, so if this one goes with this, that's T1, this one would be T2. Okay. So we got 70, wait a minute. Yeah. 75 milliliters times T2, which is right there, divided by T1, which is 273K. K's go out. 89. Okay, I'm going to extend this up. Okay, here we go, next one. I'm going to change colors just because I can. Oh, come on, give me more choices. There. Okay, I'm actually going to do red. And I changed it to calligraphy so I can do smaller. Okay, so the temperature of a gas changed from T1 to T2, right? And if its original volume, V1, what will its new volume be, V2? So we do need to add 273 here and here. So we end up with 3, 1, 3, and 1, 9, 2, right? Double checking. Okay, again, we're looking for V2. So V1 T2 divided by T1 equals 250 cc's times by 313K divided by 291K. Okay, what'd you get? We need 2 sig figs. When we added this, we got 2 sig figs.
Oh, we changed it. Why did we change it?
Okay, when we add that, you got to be careful. 360.
Wait.
360?
360.
I don't know. I'm asking. What did you get?
270. Yeah, 270.
270. Uh-oh. We got a problem here. Double check your math. Double check the math. According to our calculations. Double check that. Okay, I'm going to go back to blue so we can see the difference. 250 times 313 divided by 291. What's she doing?
You're putting 219 instead of 291. Yeah.
That would work. Okay. All right, here we go. Oxygen measures. Here's my first volume. Here's my first temperature. Here is my first pressure. What will be the volume? So I'm looking for V2 at standard conditions. So I need the pressure of combined gas loss. So pressure would be what? I want to use the same units, 760 millimeters. And what would my temperature be? 273K. Good. All right, so we do need to add on 273 to this, so it would be 283K, right? Everybody okay? So combined gas law, what is it? Okay. And like I said, I like to rearrange it first. You don't have to rearrange it first, but I like to. So I'm looking for V2. So I'm going to have P1 V1 T2 divided by T1 P2. And notice as I went through the problem, I identified what each one was so that I don't get messed up. Okay, you can go ahead and pull them out and actually say T1 is equal to this, P1 is equal to this, V1 is equal to this. But when you're in a time crunch, sometimes it's easier just to label it like I did. Okay? So here we go. P1 is 566 millimeters times V1, 380 milliliters times T2, which is 273K, divided by T1, 283K, times by P2, which is 760 millimeters mercury. Double checking myself, I'm going to cross out the units, and I end up with milliliters, which is a volume. Make sure when you go to divide, you put parentheses around that whole group.
I just put parentheses around everything.
Parentheses around everything.
Some parentheses and yeah, basically the Oprah.
Okay, what do we end up with? Remember our PTV? Remember our PTV? We're not holding anything constant here, but no, pressure, temperature, volume. Nothing's held constant here. But as I'm looking at it, my pressure, what's happening in my pressure? It's going up. What's happening to my temperature? It's going down. So I might be close to, what do I got? 280, 270 what? 270 milliliters.
Don't circle it.
I do too. Don't circle it. You're right. See me uncircling it? Okay. There. Moly, moly, moly. All right, so let's go and grab the rest of those at the bottom. We were on which one?
8, 9, 10, 11.
We were on 8, or we're on 8 now?
We're on it. We gotta do 8. We on it. Like, do on it. I'm on drugs, so I mean, psychology. I ate no warning.
Ouch. I hope we're having fun.
You ate your wrist? Yeah, I did. My wrist? Oh.
Okay, I'm going to bring that down a little bit. I can't reach that high. Okay, here we go. A volume, V, of helium measures, so this is my V1. You get rid of that one. At standard conditions. Well, I don't know what standard conditions I need, so I'm going to read the rest. Find the volume. Okay, so I'm finding volume 2. Here's my temperature 2, and here's my pressure 2. So what things do I need at standard conditions? Right, I need temperature 273 K and pressure, what pressure do I need? 760, because I want to be in the same units. Okay, whose law? Combined gas law. So P1 V1 divided by T1 equals P2 V2 divided by T2. Again, I like to rearrange first. You don't have to, but I do. T2 is equal to P2 V2 T1 divided by... Are we solving for V2? Sorry. I'm just kidding. Thank you. Appreciate it. Whoa, hello. You wanted to move the whole thing. We're solving for V2, sorry. And I'm slightly off now. So V2 is equal to P1 V1 T2 T1 V. Try that again. P2. Okay, so we do have to add 273 minus 60 is 213, right? Okay. Is there anything else we need to do before we plug in? Panic? No. 760 millimeters mercury times the volume times the temperature 2 divided by temperature 1 times by pressure 2. We don't have to as long as the volume is the same. It didn't say how it wanted it.
It does say it wants it.
Okay. I do it at the end. Just times it by 1,000. Not a big deal. Okay, so we're going to end up in liters. It asks for milliliters, so once I get my answer, I'm just going to times it by 1,000, and I've got my answer.
That's a lot.
So what do we got?
1,520,000.
So I wouldn't want it to be in liters. What is it in liters?
Liters. It's 1,520.
So 1,500. And then I'd put it over here by timesing it by this, which would make it 1.5 times 10 to the what? 1, 2, 3, 4, 5, 6.
Wait, hold on. Oh, you're trying to divide 1,000 to get it in what?
So we got our answer in liters, and then we had to change it to milliliters. Right.
Where does it say
The answer there says ml.
Oh, in gym, when you have to run the miles, I should just have this style of motivational speech.
Okay, here we go. Find the volume. So we're trying to find the volume of gas at standard conditions. So we can go again, T1, 273 K, P1 equals 760. Actually, I'm looking, it's in atmospheres. Whoa, hello.
What did you just do?
I don't know.
It wasn't that much of everything. You just ripped apart the K. Had a family.
Oh, okay, we'll try this again. P1 equals 1 atmosphere, and temperature equals 273 K. Okay, then we've got a volume 2 right here. We've got a temperature 2 right here. We're going to have to add 273, which is going to make it 250 K. And we've got a P2 here of 3 atmospheres.
Hold on, slow down.
So we're trying to find V1 this time. Now they gave you a conversion, 1 atmosphere is equal to 760 millimeters. They usually won't give you that. I don't care if it was equal to that because I know its standard pressure is 1 atmosphere. Why would I use a bigger number? Doesn't make sense.
Right.
So we're going to rearrange for V1. So V1 is equal to P2 V2 T1 divided by T2 P1. Plugging in. I basically look at, like, if I'm looking at this right here, I just say, okay, what do I want? I want that. So I take this one down and this one up. Yep. Okay, so plugging in 3 ATM times 500 liters times T1, 273K divided by T2, 250K times P1, 1 ATM. $2,000. Okay, last one here together. 500 milliliters of gas, that's my volume, 1, as standard conditions. P1, I'm looking ahead, pressure is in millimeters, so I want to use 760 millimeters. And temperature in 273 K. What would be the volume? So I'm looking for V2. Here's my temperature. I'm going to add to that 273. So you got 91. Okay, and here's my pressure too. So we've already solved for V2. I'm going to bring it down. V2 is equal to P1 V1 T2 divided by T1 P2. Plugging in 760 millimeters times volume. Was that 500? Because I wrote over it. Hoping. Times let's say V1 T2 91 K divided by T1 73 K times by pressure 2 2,000 millimeters mercury. That is a lot of pressure. No, actually things are getting major squashed.
Oh, my.
Is it 260? 60. Okay, I got a 60.
It's over 9. So twice.
60? Good. Okay, so now I want you to, you can work alone or you can work together. I want you to work on the rest of these.
Take a nap.
You got, nope, you got 45 minutes and I expect you to be almost done, if not done.
And take a nap.
Okay, before I totally release you though, I want you to look on second page at the diagrams. Okay, so let's look at the second page at the diagrams. I'm going to look at one with you, and this is what I want you to do with the other one, okay? So as we're looking at the diagram here, I'm going to make it big. Yes, but I also want you to, I know, because they'll want you to draw what's happening. So I want you to take and put 5 gas molecules in there. I don't care what gas molecule you choose, okay? But I want you to put 5 gas molecules in there. So I'm going to put 5 gas molecules. 1, 2, 3, 4, 5. There we go. Okay? I want you to show what's happening over in B with those 5 gas molecules. They're spread out more, so we're going to put 5 gas molecules more spread out. Something like this. Okay, now I probably should have picked something like a water molecule so you could sort of see a little bit better what was going on. It's okay. So if we do a water molecule over here, you can sort of see that you've got a lot more space. Okay, pick something that's at least a diatomic. So if you want to do like hydrogen or helium, or not hydrogen, not helium, there we go. You want to say, okay, what's happening here? This is my thermometer. What's happening to the temperature? It's decreasing, so you're going to put decreasing. What's happening to the volume? So you're going to put increasing. What's happening to the pressure? This is your pressure right here. Pressure is remaining constant. Good.
I didn't know that was pressure. Yeah.
Okay. What's happening to the moles? That's constant also. It doesn't have to stay constant. We're gonna do a little activity where you can see what happens with that. Okay, so you're going to be doing the next one. Okay. That's it. So just trying. If you want to, if you do, then I need to know what's happening. Now, if your pressure increases, there could be a couple of reasons for that, right? You could be shorter volume, you could be higher temperature, or you could have more moles. Those are things that would increase the pressure. Okay, so you're in charge of getting the next ones done. Yes, you can work together.